Good morning, everybody. Welcome to the CBCS morning tea and then presentations. I'd like to acknowledge the traditional owners of the land we are on and the land we are working on throughout Australia and also overseas, and show my respect to the elders past, present and emerging. It's an honor for me to introduce Bill Dennison. About 28 years ago, I was backpacking through Queensland, and in the second week, I met Ian Tibbets, and an hour later, I was sitting in front of Bill. And Bill introduced me to marine science in the sense of seagrass corals, phytoplankton, mangroves, etc. And was very fortunate to be invited to go to this beautiful place, the Moreton Bay, Kondamuka country. At that moment, I was not realizing that it was Kondamuka country, it was Moreton Bay. And luckily, that changed over time. What I learned from Bill over the years is connecting people together to work to a common goal, to basically take care of environment and the people that use this environment, to report to them on the quality of the environment, but also to let them know that we should be aware of what's happening and how we can better take care of it. And Bill definitely has led some footwork in the Moreton Bay. Then we were there for the design, implementation, baseline monitoring, the IBM program, which is basically, I would say, the basis of healthy land and water. And also the ecological health monitoring program that is now still running, and there's report cards that are still going out that are all coming from that time frame, which is amazing. Bill, thanks for introducing me to marine science, but also thanks for coming here and to this talk.
Thanks, Chris. So I decided to title this talk "The Science and Art" because it's not just science to produce these social environmental report cards. This is our most recent Chesapeake Bay report card. And I'll discuss the evolution of report cards and how they work.
It might be, I might have turned it off, the interim.
We practiced beforehand. Is there a forward button?
There we go.
Okay, you got it working?
Yeah.
All right, so I arrived here at Goddard Building in 1992. In 1992, the Prime Minister was Paul Keating. The captain of the Australian cricket team was Alan Border. And this was the University of Queensland Botany Department that we shared this building with zoology. South Bank wasn't even built, just to give you. There were no city cats. There was no green bridge. We took a little ferry across the Brisbane River. So I formed this marine botany group. I used all my startup money, all $40,000 worth, to buy a tinny. And so we had a boat to go out into Moreton Bay. I had some ordinary graduate students like Chris and Simon Costanzo here, and Pelagia out at the research station. I had an assistant who was doing a degree in art. So during her lunch breaks, coffee breaks, she'd come into the postgrad room and paint this fridge. Beautiful mangroves and seagrasses, and so well, those are good. So we developed that into a whole set of symbol libraries and science communication products. And we generated a series of books and newsletters. I gave lots of talks around town, council chambers and church basements, talking to people about Moreton Bay and the relevance and the waterways and how we needed to keep them healthy. So that was how we kind of got into the point at which we were, so let's do a symposium associated with the River Festival that the Lord Mayor Jim Sorley had started. So let's do a symposium. And at the symposium, the organizer said, well, why don't you come up with a report card for the Bay? Okay, we can do that. So Simon and a few other, I think about half a dozen of us, post-grads, sat around the table and said, well, Bramble Bay, that's the worst. We'll give that an F. The Eastern Banks with the dugongs, turtles, seagrass, we'll give that an A. And then we'll just kind of fill in. And we just made it up. Seriously, we just made it up. It's like, well, that's better. We'll give it a B, we'll give it a C. And thought, well, that's pretty clever. And there's a quote by Mark Twain, there's something fascinating about science. One gets such wholesale returns out of conjecture, out of such a trifling investment of fact. That's exactly what we did. We generated with that from the fridge art that I shared with you. We generated this diagram of the green, brown, and blue of the Griffin River and Moreton Bay, which ended up being the color scheme for our Healthy Waterways logo. And the idea that you had this turbidity and then algae if the sediments dropped out, and then the beautiful eastern banks. Turns out people paid attention to the stupid report card. It was front page news. We just made it up. So there's a little confronting. Maybe we should, as a scientist, maybe we should do something like measure stuff and use data. So we created that Chris mentioned, the ecosystem health monitoring program. We were able to then expand into we separated out what we call the river estuaries, because for about 360 days a year, they serve as an estuary, fresh and salt water. A few days when it rains, they turn into rivers. Versus the Moreton Bay out here. So we developed something that was a little more rigorous and a little more defensible. In fact, I think in November they released their 25th anniversary of the report card. And it got buy-in by our local politicians. This guy was the mayor of Redcliffe and then became the mayor of Moreton Bay Council, Alan Sutherland, and he talked about it. One of the things Alan, when he was mayor of Redcliffe, told us after we went and presented data that Simon had generated with some Delin 15 mapping of macroalgae out in the Deception Bay and Bramble Bay area, was that the Redcliffe sewage treatment was contributing to the problem. You couldn't blame everything on Lunch Point and the Brisbane River. So as a result, they voted the single largest expenditure in Redcliffe history to upgrade their sewage. And he said, we don't get elected on sewage, we get elected on parks and roads and things, but it was the right thing to do. So I think, and then they shamed the rest of the councils into upgrading. And in fact, by 2000, we had tertiary treatment across the big sewage treatment plants of Southeast Queensland. And we expanded the report card. We hooked up with Stuart Bunn and his mob out of Griffith Uni that did the catchment studies. We went up to the Sunshine and Gold Coast and did report cards for all the subcatchments, which again is happening to this day. And report cards then, we went around on the road and shopped it, and we did Great Barrier Reef and Carl Mitchell and others worked together on Great Barriers report card, and Simon and I went up to Darwin Harbor, and et cetera. So report cards very common now. So I went back to Chesapeake Bay and I said, well, this is a model. Let's try this out on Chesapeake Bay. And it turns out Moreton Bay and Chesapeake Bay are about the same ratio of catchment area to bay area population, except it's a factor of 10. So Chesapeake Bay is 10 times the catchment, 10 times the bay, 10 times the population of Southeast Queensland. So it's a proportional, but larger scale. But Chesapeake Bay is on the east coast of the United States, includes 6 US states, half of Pennsylvania, all of Maryland, and half of Virginia, includes the national capital, Baltimore, Norfolk, the big cities. And it's a drowned river valley. So the deeper areas in red and orange here are the old river valley of the Susquehanna River, which extends up into New York State. But the rest of it's very shallow. That makes it very productive and very vulnerable. And people had been working on Chesapeake Bay long before I got there. They started in 1925 when they formed the Chesapeake Biological Lab and basically invented estuarine science. The physics, chemistry, biology, geology, two-layer flow, how estuaries retain and trap nutrients. And then starting in the 70s, particularly with a tropical storm Agnes that occurred in 1972, eutrophication science became evident, needed to understand why it was degrading, why are the aquatic grasses disappearing, why are the algal blooms appearing. And then that led to a series of research studies that led to the formation of the Chesapeake Bay program in 1983, where a watershed scale approach with the relevant state and local jurisdictions, putting together a monitoring, modeling, and management program. And then in 2002, I came back from University of Queensland to University of Maryland Center for Environmental Science and set up the Integration Application Network, which is what we call boundary, a spanning organization, sitting between policy and science. So we had scientists, trained scientists who had degrees in science, but then learned graphic arts, learned facilitation skills. And we combined two things, studying and solving problems. So these are kind of like a right brain, left brain thing. So to study a problem, you have to be objective and dispassionate. To solve a problem, you say, I care about this place. It means something. To study a problem, you have to embrace the complexity. You have to simplify things. It's all about the nutrients, for example, for Chesapeake Bay. You have to publish and get funding via the peer review system to study problems. But when you're solving problems, you have to reach out and do that same kind of engagement, but with stakeholders, non-scientists. Ultimately, to study problems, you have to get it right, no matter how many drafts, no matter how many iterations it takes, you got to get it right. But to solve problems, you often have windows of opportunity, you have to get it done. I was reading in the early days of the Healthy Waterways program, and the guy, sewage engineer, approached me and said, we need to know how far we should build the pipe coming out Pine River's sewage effluent should be. We're debating between 0.5 kilometer and 3 kilometers out into Moreton Bay. What can you tell me? I said, great question. We just got funding. We're going to have within a year, which is really fast by science standards. We're going to have models, we're going to have drones, we're going to have figure out a good answer for it. And he said, Bill, we're going to decide tomorrow. What are you going to tell me? And that was like a revelation that we're managing with imperfect knowledge. We're making our best guess. Of course, I told them, go as far as you can, which they did. But the difference here is that we had to get it done in that time period. So what's the challenge of combining this left brain analytical stuff with this right brain creative stuff? How do you combine it? Well, the human brain does it with the corpus callosum, its two hemispheres. In fact, when they've analyzed Einstein's brain, that's the difference. He had a big corpus callosum connected left and right hemispheres. we can do that, and that's what we aim to do with our integration application network. And then much more recently, we formed a Chesapeake Global Collaboratory, which is one thing going forward, we collaborate with you guys. We call it not just a think tank, a think do innovate tank, where we've got National Science Foundation funding to hire data scientists to focus on big data. We are engaging with increasingly diverse groups. Typically, environmental field, you have the people you already know. The same characters show up. We're trying to reach beyond that and get the disenchanted people involved in the decision making, and then deal with these increasingly complex problems that we have to face. But coming to Chesapeake Bay from Moreton Bay, where we didn't even have a monitoring program, we had plenty of data, but it was sitting on shelves. We didn't have the synthesis. So that's where the report card came in. So when we started looking at this, there were literally 101 indicators. And this is a screen grab from their website. 101 indicators, but they included like the state of environment, like how much seagrass is out there, but also the management and response. How many did you plant? That's very different. There's no hierarchy, no combined indices, and you could tell whatever story you wanted. You could do the happy talk. Oh, look, we've planted a lot of oysters. Aren't we great? Versus the doom and gloom that the NGOs were saying the bay is dying, we got algal blooms, we got these problems. So it turned into what story you're going to listen to, because we didn't have a common theme. So they got busted by a Washington Post expose, a local newspaper, by a book called Chesapeake Bay Blues that really forced the issue that, hey, we need a way to move forward. So that's when we produced, that gave us the ammunition to produce the first Chesapeake Bay report card. We had plenty of monitoring stations, plenty of data, water quality, our benthic index of biotic integrity, and our aquatic grass surveys. So we produced a report card, just like Moreton Bay, got plenty of news. At least this time we didn't make it up. We actually had data. And it caught the fancy of our governor of Maryland, Martin O'Malley. He had created a crime fighting thing, CompStat, emulated at New York City to reduce crime in Baltimore, which successfully had the crime rate. And so he wanted to stat everything. So he created Baystat. So this was him at a TED Talk talking about. So we used the report card in the space that we sat once a month with the governor and his staff in a room about like this, talking about nutrients. And in fact, after 6 months of talking about chickens and chicken manure, said, "Is this another chicken discussion?" Yes, Governor, we're going to understand this. And then with Simon, we ended up, we felt like the garage band that got discovered by the record label, WWF, came in with their big box, and they created the Healthy Rivers for All project. So one of the things we did is surveyed all the people who were doing report cards at this time, and we found out that 80% said they're really good at increasing awareness. Only half said, yeah, ended up with a positive impact. 86 said that they increased the demand for additional information. Surprisingly, almost unanimously, they said they would recommend doing it for other groups. And I think that's one of the reasons word of mouth, they spread. But here's what I want to work on here. We're not doing this report cards just for the science of assessment, but we want to do it to create positive change. Did I do that?
No, that's the audio isn't on Zoom, so I'm trying to figure out why that is happening.
So they're just seeing me, not hearing me.
Yeah.
Oh, those poor people. Well, start the next one when you do it.
Okay, they said I've got it's fine now. Oh, they can't hear the videos.
Oh, the video. Okay.
Okay. So, but you are good.
I'll put it on you've got it, so maybe we can figure out a way to do the recording. Can we go forward?
Yes.
So we went off to far-flung places. We were in Mongolia, South America, Africa, Asia, North America, Europe, etc., doing these report cards with not just WWF, but a bunch of different partners that were interested in doing these kind of assessments. So we kind of created this environmental intelligence pyramid that kind of summarized what report cards did. So you always have to have the data, foundational data, and then the technical support with our management community, summary reports to the stakeholders, and then ultimately targeting general public and decision makers, our report card. And that's the highest level of synthesis, but the lowest information density. I think it's really important to recognize that report cards have to come with the rigor and they have to be trusted sources that have the data to support it. So if there are questions, you can drill down to the data and say why you're making these assessments. So we created a how-to booklet series. The first one was the practitioner's guide. We did an indicator, and then more recently a tool guide for stakeholder engagement. And they're all available as PDFs on that QR code. And I think they work because this one here was there was a group from San Antonio, Texas, that won the TEAS International River Prize. They came to Brisbane and received their prize. And they said, well, that report card sounds like a good thing. So they went off and did their own report card just based on what they read in the book. They didn't consult us, except when the press event came at the end. They asked me to come along. So the only reason I knew about it is because I was on the media with them. But it was great. They did that. And San Antonio was a great case study because it's instead of environment versus economy, they're cleaning up the river, and the Riverwalk created better economic outcomes to extend the Riverwalk. So they combined economic development as well as environmental improvement. We also, during COVID, had nothing better to do but sit around and generate some online courses. So we had a course in science communication. We made a course in developing report cards and a couple other science management courses. And they're available on edX, so they're free if you just watch it, and then you pay a little money, then you get a certificate. So you can have a look at the how to do these report cards if you choose. But really, this is all leading up to, this is a big preamble to what I consider my evolution in the science and art of report cards, starting with the outreach phase. And that's where the investigators, the scientists, got together, like that table we collected my postgrads around and made up that first score for Moreton Bay, delivering that to the public, to the mayors and the public. And that outreach is really important because you can change the public dialogue. So we've been doing the Chesapeake report card for about 10 years. When we finally got to the point where we could detect a measurably improved water quality, ecosystem health, great. And that's why we put the report cards like that. And that changed the public dialogue so that, in fact, the NGO, the Chesapeake Bay Foundation, responded because they had been talking doom and gloom. Give us money, the bay's dying. And they, no, we're actually improving. They got worried. So they actually commissioned a survey company, Opinion Works, to go out and find out whether the knowledge of the bay getting better was going to reduce people's willingness to donate or their willingness to change behavior. What they found surprised them and me, which was signs of improvement gave people more willing to spend money, more willing to do more. Positive reinforcement was much more powerful than the bay is dying. So that was really interesting. And we went and linked our aquatic grass recovery. We took a picture of one of the giant grass beds you can see from space up at the head of the bay to illustrate that for this. So I think it became evident to me that this is a chance to champion the scientific results into a public dialogue. But that's a bunch of scientists talking down to the masses. So we needed to start developing more collaboration, more engagement, more user-inspired research. So that took the case where we created stakeholder listening sessions. So we went out to the public, set up these tents and out to work. Kind of COVID era, you didn't want to be inside anyway. And we gathered together and we asked them, what do you value? Well, first, where do you live? Where do you play? What do you value? What are the threats to those values? What do we need to measure? What's your vision? What are the actions you recommend? And we were able to get really good input. And we started originally with like the riverkeeper groups, the people already involved. Then we started going to the African American church service and going after their church service. So we reached that community. We went to the farmers market next door to the farmers markets. We were going in and grabbing people. We went to public parks. We went to places where people gathered and went out and drew them in to participate in this, so we could get a much broader swath of input. One of the things we learned from this, and this was a dissertation that Vanessa Vargas Wynn put together, was people cared. Yes, they cared about the fishable swim. We expected that. They cared about the transparency and accountability of the report cards. But they also cared deeply about fair and meaningful participation in environmental decision making, about having diverse local knowledge input, to having sustainable practices in ag and urban areas, to have active citizen science programs. We created the citizen science program in 2015. It's been very successful. We just got 1 million data points recently. Kind of like what Chris does up on the reef with the citizens of the coral reef. Protection restoration is funded and valued. So we recognized we needed a much bigger net to catch this. And so we developed indicators. We went and did a short course essentially with a group called Council Fire that are economists. And so we went and looked at some economic indicators, not like gross national product, like how much the corporation made, but in fact, what's the median income? What are the jobs available? What's the income inequality, the Gini index between the haves and have-nots, and housing affordability, the things that most people care about. We also did our standard ecological indicators, the fish, the bugs, the water quality. We also did some societal indicators like surveying, citizens, what kind of behavior, volunteerism you have. We looked at heat vulnerability. We looked at a social index that the Center for Disease Control put together for social vulnerability. We did walkability. Can you get to a park, a green space in 10 minutes? And we put that together. And that's where we started developing what I call this co-production or transdisciplinary research, where you're not working alongside, you're working with. Anybody heard the word transdisciplinary? About half. Okay, so it's a complicated word. It's a big word. It's an academic, geeky word. So I worked with one of our colleagues here at ChemEng, Kate O'Brien, and we wrote a former science communicator down at NC State, and we wrote a paper on transdisciplinary called The Recipe for Success in Working Across Boundaries. It came out earlier a year ago now. So here's the fruit metaphor. If you want to be disciplinary, you stay in your lane. You have your separate bowls of fruit. You've got your oranges, your bananas, and your apples. Okay, everybody's happy. You can separate. Or you can work alongside and create a fruit tray. You can lay them out and pick off the fruit that you want to eat. Or you can create a fruit bowl when you work with and mix it all together. Have them all together. Transdisciplinary is when you put that fruit bowl into a blender and you make a fruit smoothie. And the product then is valued, it's trusted, and it's accessible. So we call this co-creation process where you bring your knowledge holders, your disciplines together, use the right tools, you bring the right people together, you set up and maintain effective communication, create a shared language, put them in the connector, which is what some of us scientists should try to aspire to be, to create this co-created outcome. So that's our fruit metaphor definition of transdisciplinary. And we wrote that paper without using the word transdisciplinary. Okay, so let's look at that broader suite of indicators and how that influenced what we were doing. So in 2022, we started seeing overall the bay is getting better, but then when you get down to the 15 reporting regions within the bay, lots of good stories up here at the top of the bay where that seagrass recovery I was talking about is. Some good news down at the lower bay. But over here on the eastern side of the bay, the eastern shore, there's this degrading, and the second worst grade after the urban areas was this very rural area, Chesapeake River. There's a problem over here. And when we look at the streams that run into the bay, yeah, they're full of nutrients, and the bugs and fish are not thriving. So it's an environmental disaster. But it turns out it's also a social disaster. It's actually an economic disaster if you measure the economic indicators that we use, which are about the people, not the chicken industry. It turns out this is a chicken area. They call this little peninsula Delmarva, Delaware, Maryland, Virginia. So that's the Delmarva Peninsula here. And so this opened up the opportunity that we have a systematic failure. So we went to the chicken industry and said, we got to figure this out. So we followed up with a little more details about what's going on this eastern shore of Chesapeake Bay, this peninsula. And you see it's mostly agriculture, the yellow with forestry, very little urban area, lots and lots of chickens. Some other livestock, mostly corn and soy to feed the chickens. And then the chickens are exported. But we can't even grow enough soy and corn, so we import it from Iowa and the Midwest, bring to Maryland. Why all these chickens? Well, I'll tell you that story in a minute, but we decided to co-produce with the Delmarva Land and Litter Collaborative, which is a chicken manure group. Use that euphemism, but it's all about chicken manure. The Chicken Association, you can see one of these chicken houses, the Farm Bureau, the grain producers. The chicken industry started by an accident. A housewife ordered 50 chickens. Well, she ended up ordering 500 by mistake. She thought she was ordering 50 chickens to grow for laying eggs and stuff. Well, then she had 450 extra chickens. She sold them, made some money. So next year she ordered 1,000. And it continued to grow. So out of this little, and that's Cecile right there. So it turns out now it's a $4.2 billion industry. And these chicken houses, these long houses, they're free range. They're not in cages. They're not outside, but they're not in cages. The lights are on 24 hours, keep them growing fast. They selectively bred them. They're big, giant. They barely can stand up. They're so big. So there's this massive chicken industry. So we gathered our scientists together and said, why? And basically, this is co-production. We don't know the answer. We don't know, as scientists, we don't know why things are going badly on that eastern shore. Yes, there are a lot of chickens, but what is it that's actually causing the degradation? It could be that we have the highest application of cover crops, winter cover crops in the country. So we're doing good things, but it's not working. Maybe the lag times are so long. Maybe the climate change. Maybe it's that we're over fertilizing with nitrogen for the yield goals to balance our phosphorus base. Chicken litter, we call it chicken litter, again, euphemisms for chicken manure. So here's a quick summary we did of what's happened. We've increased poultry. It's, well, obviously since 1923, but even more recently, it continues to increase. We're applying more manure. We've got tremendous amount of best management practices applied. Our ag fertilizer use is starting to target nitrogen. So we're not making progress against our goals for nitrogen. We're going the wrong way, but actually phosphorus, we are solving the phosphorus issue. So this was a paper that we did where I just tried to find out where the poultry houses, as they call them, are, and they don't put that information in. So we went to satellite and just manually counted the number of poultry houses that we can see from space. And you can see that the Delmarva Peninsula is riddled with these poultry houses. You can smell when you drive across. And then we looked at some data with our colleagues at USGS, and we found that if you look at the nitrogen that's removed by the crop, you can see this is a negative, and then you can see when you have soy, you get the nitrogen fixation, and then you fertilize it, and then you apply a manure. So the net result is everything above the line subtracted what's below the line. The net means that we've got this flux, this increased nitrogen. Phosphorus, as I said, is actually stabilized, and that's because of a regulation, the phosphorus management tool. Regulations work, volunteer, not so much. We've got this fantastic cover crop program. We had to up the goal because we were exceeding it. We had Governor Mallard that you saw very active in promoting these cover crops. It's an inducement. The farmers get a subsidy for planting a crop over the winter, the fallow period, and soaking up the excess nitrate. So it's a good thing. But when we started looking at the total amount of nitrogen applied versus the yield in crops, we started seeing a discrepancy here occurring in this period when our report cards started showing these negative trends. Phosphorus, pretty much tracking. So the phosphorus is being managed properly, the nitrogen, not so much. The farmers are telling us, but we're changing what we're doing on land. We think that it's just a lag time, and it could be partially right. When you look at a groundwater residence time on this peninsula, it's very slow, it's very flat. The soils are very heavy, lots of clay and silt. Doesn't percolate well. So the average lag time is 29 years. So in some places it's like 100 years. It takes a long time. So maybe what's happening, they've gone to no-till in that 29 period. We went collectively to no-till. They've gone to precision ag with injection of manure rather than applying to the surface. So there are a lot of things that have changed. Perhaps we'll see improvement in the coming years. Meanwhile, though, climate's changing. We have warming temperatures throughout the bay and the watershed. We have increased precipitation, particularly in the winter. We call it warmer, wetter winters. So we're not getting snow so much except this year. We're sitting here and there. Chesapeake Bay's frozen the first time in several decades. But basically, it's definitely seeing the effects of climate change. So what we recommended and what we're moving forward with, and this is of relatively recently, to unravel this cause, working with the farming community, with the Chicken Association, we're going to synthesize our existing programs, in addition to the Bay program data, the riverkeeper groups, the citizen groups, the state agencies. We're going to develop some targeted monitoring. We're going to redeploy the monitoring resources to address those specific Delmarva issues and try to crack this together with the farming community rather than us going off on our own. So, as a result, I think this is what we're talking about, the fruit smoothing. This is where we're working collaboratively in the transdisciplinary approach. But it takes many years to develop these trusted relationships, and it's not an overnight success. The final slide here is a paper that we just recently published on lessons for other ecosystems from the Chesapeake Bay, and my co-authors here are all retired except me. So we have like 500 years of collective experience and knowledge, and we came up with, we have to think about the governance, the implementation, and the adaptive management, the adjustments you make in the process in order to have an effective restoration program. All of that before the current federal administration. The good news is the current administration, even during the government shutdown, maintained the Chesapeake Bay office. The funding levels have been maintained. So once again, I think the success that we're seeing empowered them to say that continued investment in Chesapeake Bay is worth its time. So that's my story, how it all started here in Goddard Building many years ago. and now has evolved into a co-production using report cards to help affect positive social change. Thank you. I want to acknowledge the Marine Botany Group here. And then like 6 of them came over and worked with me over the years with the Integration Application Network. And then this woman over here who, sight unseen, moved to Australia with me. And we were telling me how to drive the boat up in Paranoi. And Judy O'Neill, who also has been involved in all the Chesapeake as well as Moreton Bay stuff, including Lingia. So thanks to Judy for putting up with me.
Thanks, Bill, for a very interesting talk. It's time for questions, so anybody who has a question for Bill?
I'm just interested in the funding model. So you get a lot of your the money to do the work that you're doing in Chesapeake Bay from the government, because just wondering, our role as scientists at university, obviously it's very different in Australia and in Moreton Bay, where a lot of the money is going to health development water to do these report cards. So I'm just wondering if you had any comments about how things might be different in Australia to the US and how that funding might be different.
Yeah, that's good. A good point. The funding at the beginning of we created Healthy Waterways program. Nothing. There was nothing looking after Moreton Bay at the time, and they've actually grown quite a bit. I'm surprised at how large they are. Our funding in that we got from them was threefold. We got land care money, the federal government, we matched it with state money, and then the local, at the time, 6 local councils. So it's a 1/3, 1/3, 1/3. And I think one of the best funding models always is a shared funding model. So if one starts to pull out, the others say, "Oh no, you got to stay in." So in Chesapeake Bay, the federal money then gets apportioned to the different states. We also, scientists get a lot of their money through competitive grants and contracts with state, federal, different agencies, National Science Foundation, et cetera. So one of the challenges we have is always in both Moreton Bay and Chesapeake Bay is ensuring that the science is relevant to the being addressed by the decision makers. It's one thing to study, the evolution of a shrimp or something. That's great science, but if it doesn't apply to the management of the bay, it doesn't provide that kind of positive feedback. So we're always trying to figure out better ways to integrate the science with the management. To be, I think in a way, and people used to call me up throughout Australia, how'd you get the money? How do I get the money? And the money comes secondarily. You do the project, you do the work, and the money comes. People find ways to fund this, support that activity. That's always been my attitude. So start doing something with whatever media resource you have, and you can compound it and leverage it.
I have a question from Nissa Henry online. Hi Bill, have they done some process modeling of the land management changes to model out the time lag effect like we do for the Great Barrier Reef catchments?
Model the time lags. Yeah. So, one of the things I didn't even touch upon in this whole talk is I've always focused on the monitoring and the data. Both programs, the Great Barrier Reef, Moreton Bay, Chesapeake Bay, have lots of modeling. And modeling is really important to come up with your goals and your apportion people's and look at what kinds of activities will create the best impact. The problem with the models is if you start to believe them, and all models are wrong, some are useful. So I've always kind of erred on the side of data for the monitoring because there's more credibility with it. There's less explanation you need to go through. I think doing the models is really important part of designing a good program. I think it's really important for planning, but for communication beyond your scientific group, I think it gets problematic. I think you often get stumbled And my first task when I met with the farming group was to say, we're not here to talk about the models. And they all want to complain about the model. Well, the model's not counting this, not counting. Look at the data. This is what we're dealing with. Let's just focus on this. And I had to keep pounding that into them because they wanted to use the model as an excuse not to act. So models are important, but used properly, I think. Yep.
I was wondering if you could talk a bit more about choosing the indicators. My experience is there's a lot of potential things that scientists like to monitor. Only you've got to narrow that down to a reasonable number.
Yeah. That's choosing indicators is a whole subject of series of science workshops you have to work through, but you have to go back to the values. What do people care about? And you have to measure the things people care about. And we do report cards around the world. Not one report card is the same. You know, that in the Orinoco River, it was the blind river dolphin. That's what they care about. We don't have blind river dolphins, so I'm not gonna worry about that here. You get in trouble. We did a national set. I did 2 national assessments: Australian estuaries and U.S. estuaries. And shoot me if I ever try to do another one, because they're flawed, because we used one set of indicators. And it turns out in Chesapeake Bay, we wanted clear water, we wanted aquatic grasses. In San Francisco Bay, on the west coast, they wanted turbid water, and they wanted to get rid of the invasive aquatic grass. Turbid water for the delta smelt, and clear water for our crabs and oysters. So we're measuring the same thing, we want different outcomes. That's just one example. That's so every place you go, the process is important. How you define what those indicators are, what you measure, and it really turns out our science colleagues get wrapped around what the threshold, the proper threshold. The thing is to be transparent about whatever threshold you choose, come up with a rationale, why that threshold, and go with it, rather than obsess about the perfect. There's no one perfect indicator, it's the assortment of indicators. We actually did a study supported by the National Park Service where we measured 23 different indicators, and then we randomly selected 2, 4, 6, 8 of those indicators. And it turns out once you get about 6 indicators, no matter which you choose, you end up with the same answer. So our magic number for indicators generally is, can you count them on your 2 hands? Do you have to take your shoes off to count? No, just your 2 hands. Don't use your toes, and you're going to get there. But more than 5.
Okay, more to that. So we have all the data, so much data, so many models, so many report cards, all of those things.
Yep.
We know the water problem's grim, the situation's grim. So if you were the boss and in charge and you came back and got to say, this is what we're gonna do to fix things up, what would it be?
Well, it turns out I was invited to come to the 25th. They invited Jim Sorley, who was the mayor when I was there. And Jim asked the right question. He said, well, we cleaned up the sewage, we got that under control, pick that box, but what are you doing up in the catchment? How come you haven't changed that? You're still talking about the lockyer, you're still talking about the dirt and nutrients that come down. Because I would show the map of the catchment, I said, that's your fertilizer, that's your dirt, and that's out in Moreton Bay. That's not good. You want it up on your paddock. So to me right now, and why I'm spending all my time with farmers, it's creating a sustainable food system. It's got to be our focus. And I call that sustainable food system because it's not just the crops, it's getting that crops into our bellies eventually, because there's so much loss. We only get like 18% of what's grown into our bellies. It's going to be important for climate change. It's going to be important for water security. It's going to be important for nutrient management. It's going to be important for human health. We can't just eat bad food all the time. So I think sustainable food systems. So I would be up in the lockyer talking to the farmers. That's where I'd spend all my time. And that's what I'm doing in Chesapeake Bay, spend my time with the farming community. Yep.
Bill, you talked about restoration of past events, and this may be out of the scope of today's discussion, but future events are very important in Moreton Bay, and I'm thinking particularly of the Port of Brisbane's channel enhancement project, where 96.5 million cubic metres of soil will be dredged up and placed somewhere. Do you have a prescription for future events?
Well, we have the same issue in Chesapeake Bay. We dredge to maintain the shipping channels for the Panamax, the post-Panama Canal expansion. So we have to have a 50-foot controlling duct at a certain width. And it naturally is filling in, so we have to continue to pull that sediments out. We created $1 billion island where we put this. And we're creating the next set of islands as that fills up. For the Baltimore Harbor, where the more contaminated sediments, we have a separate dredge location. So, and it turns out, the Port of Brisbane's actually funding tree planting upstream because ultimately they have to dredge less sediment. I think that's a smart move. We're doing the same thing with the Maryland Port Authority. They're helping us with some restoration on land restoration. But, that issue of maintaining active shipping channels for our modern transportation connectivity that we have is a real issue. And I think bringing those people into the conversation so that you're creating sustainable solutions. Right now, we have, due to regional sea level rise and land subsidence, so we have a sinking Chesapeake Bay. We've lost 13 inhabited islands that are not inhabited anymore. They've disappeared. We've got salt marshes that are eroding. They're sediment starved. So here we have places that need sediments and too many sediments. So we ran a workshop and said, well, why can't we just get you guys together, put those sediments over here? Well, it's an economic issue of what it takes to do that. And so they're even talking about dredging out behind the dams that are filled up. So we really haven't cracked that nut yet, but there's big dollars behind it. So my suspicion is if we can create enough momentum to get those dollars to be applied to the right thing, we can use those sediments for beneficial use. What they call it, thin film irrigate applications, so it can grow and maintain the marshes, which are disappearing. So that's an issue that you see around urban development throughout the world in these world harbors that we really have to figure out. Yep.
I have a sort of building up on Carissa's question. When you go and talk to the farmers, how do you sell to them the importance of caring about the bay or either bay? Because it seems like, the agriculture happens on land, obviously far away down the stream kind of thing. And secondly, logistically, as far as governance goes, because at least here in Australia, I'm not sure about the US, it's kind of a bit of a separate matter what happens in the sea versus what happens on land. How do you kind of marry them to actually have some outcomes?
Well, the place where we work in the Pennsylvania upstream for us in Chesapeake Bay, the farmers don't care. They've been preached at about oysters and crabs in Chesapeake Bay for generations. It hasn't worked. So we don't do it anymore. We don't go talking about Chesapeake Bay. We talk about their streams and their children that are accessing their streams and their farms. And we go to the farm show and we talk with the farmers in that setting. So I think it's really taking away the bay and just talking about looking after your patch. If they look after their patch, everything else will flow. So I think we got to quit trying to convince people in the Lockyer about the dugongs of Moreton Bay. Let's talk about the Lockyer and primer, the tributaries into the bay. I think our conversation, and it turns out, like a lot of these farmers in Chesapeake Bay, pretty wealthy. These landowners, they could sell off a couple pieces of their field and cash in immediately. They've got boats and they join yacht clubs. They like to recreate on the bay, but we just focus on the farm and what's happening with their local streams. Nobody wants to be preached at. And when we've got our governor of Pennsylvania, we went up and did a report card last year in Pennsylvania, a release up there. Their governor came in, and at first he wasn't going to come up. He said, I got, the day I started my governorship, I got sued by the Chesapeake Bay Foundation. they slapped a lawsuit on my desk the first day of my job. Are they gonna be involved? No, we're the university, we're doing report card. In fact, we've got a problem in Eastern Shore, but you're looking pretty good up here in Pennsylvania. So I said, I'm all in now. He's chairing the sixth governor panel to run the Chesapeake Bay. Is very supportive because we're not beating him over the head and we're talking to him and his team. So I think it's just being good citizens and working with these people and not beating them up. And I think that's part of that co-production is that, we're in this together. We're trying to figure this out together. We're trying to solve this together. What resources can we bring together?
As far as management, you kind of go higher. Cover level, cover both.
Yeah, well, it turns out, I think, here's my thought, is that because the report cards generate media attention, the politicians care. It's not actually coming up through the ranks. So they're reading the news, they're listening to the chatter, and that's what they're responding to. So I feel like that's why you have a media push with that. So that gets their attention. And then that sets the direction and the funding that fans out into the agencies that we work with.
So I have to close down, but I'm going to take the honor to have one last question. And you say the media has attention. You also wrote that, or said that the science, if it shows evolving, it shows improving, but that has an effect. Should we talk doom and gloom, or should we talk happy things?
I think that's a really good question, because what we have to do is thread that. We have to be honest about what's not working. No happy talk, but we have to celebrate those successes even if they're small. And actually, facing climate change and population pressure, it's hard. It's hard to find those nuggets, but I think it's really important to celebrate those because then it empowers people. Look, we solved the nutrient problem. We cleaned up our air. We've got catalytic converters. The air is cleaner than it ever was. We've got sewage upgrades. You can swim in Baltimore Harbor now. Brisbane River, if it weren't for the sharks, maybe you can swim. But celebrate those successes. Make a big deal about it. Empowers people to take on that next challenge, that next harder thing. But so our report cards are always good news, bad news, and sandwiched in with here's and ending with a little of an upbeat. But we can't hide the fact that we've got and we've got to solve it. But I think that's a really good question. Look, I'm sorry I didn't get to answer everyone's question, but I think you're posting this online, and so if anybody wants to put a chat question, I'd be really happy to do that online or afterwards. I can talk to anybody. I'm here for the duration here, so I'm sorry I couldn't. I can talk about this all day, but I know we have to move on. So thank you for the opportunity, and it's great to be back here at University of Queensland.